Hello everyone. Today let us discuss about an interesting topic, which is how the data flow happens to Snowflake and inside Snowflake. Like what are the types of orchestrations that we have, how the data flow continues, all those things we can discuss today. So if you see on the screen, so think like this is like a source database which which is actually storing the data in the source system. Okay, so now from here, the Snowflake data will be the data will be moved to Snowflake by three cloud systems, right? We have three cloud systems where Snowflake supports this data flow into Snowflake. Okay, one is Azure, AWS, and GCP. Okay, so now let us take clouds. Okay, let's copy. Okay, so these I mean think like these three are clouds. This is Azure. Okay, so this is AWS. Instead of this, let us write here itself. AWS, GCP. Okay, so this is the landing zone. We can say landing zone would be these three. So once the data landed to cloud storages, this can be happen through multiple ways, maybe using producers, maybe through Python, maybe some other ETL tools, whatever you can use, whatever the maybe Azure Fabric, ADF. So any of these uh, systems you can utilize to populate or to push the data or pull the data, push methods, pull methods. If you are using APIs, you can get API, and so these are a number of ways where you can get the data into your landing zone. Once the data is landed, so that's where our the extraction part will start. So either it is like a streaming, for example, you can take a streaming method, or so here if you see streaming, here batch. Okay, either of these methods you can use it. So in batch method, you can see like a copy into statement you can use in Snowflake. For streaming, you can use pipe. So let us draw this. Okay, go to the shapes, take this. Take, okay. And from here, okay. So from streaming again, we how to process streaming data can be processed through Snowpipe, and the batch job will be processed to copy into command. So the streaming job will be process the data through Snowpipe, which is almost near real time, probably a 10 seconds latency. So that will that much, 10 to 15 seconds. But batch will be based on the schedule time. So if we schedule a task, so again, I'll go into deeper now. So it will be used for copy into. So it's like a based on the demand, the batch will be, right? So now let us take the next approach, how we are going to process the next data. Now streaming data, let us take, okay, here, stream data will be snow pipe, and here copy input. Okay, so now how this snow pipe, this is like an auto ingest. So let's take another one. From streaming, what we will use. So from copy into, we can again process the data into a staging table. And once the stage landed, so we can, let me open up something like space. Okay. Now we have seen from streaming, using streaming, we loaded into a stage table. Okay. So from stage, we have how the data will be pulled is like there are multiple ways. We can create a stream on stage table. Okay. So what the stream does is it captures the inserts, it captures the updates, it captures the deletes. So all these data will be whatever the appends, whatever the appends that are going to happen on the stage table, they will be processed to the stream. So next, based on the stream information, we can create a task which can orchestrate the procedure or a statement or so these things they can be orchestrated to be scheduled to run at a specified interval of time. So right now it is minimum is 10 seconds, but preferred will be 60 seconds because there might be dependent tasks need to be run and then take care of all the proceedings, right? So how the orchestration happens is based on, suppose when you landed the data into stage table, as part, I mean, stage can be named to branch as well, branch, and which is as part of the medallion architecture, stage can be named to branch as well, and silver and gold. So now the data which is landed on the stage table, which is going to be always like maximum, it should not be having any updates or anything. So let us better to have always the appends. So no transformations, pure append kind of ingestion with varchar data type. No data type changes also. Everything you make it as varchar. So now you have the stage table, which is a branch, right? Branch layer has stage tables. On top of that, you created the string. So now your task is to process that data into silver layer. So silver layer, if you are going to use Snowflake as an ETL tool or ETL process, for ETL process, you can create your control flow by using procedures. Okay, so you created the procedure, but you have to, procedure cannot run on its own. Somebody has to call it. For that reason, so we are going to use tasks. That is what we explained in the first thing here. So this task will check for stream data. If stream has data, then you can trigger the procedure or a statement. It can be an update also, right? So this is what will happen. So now, as part of this, in the first step, where is the metadata? So we have to maintain the metadata like our logging. So logging through existing metadata tables, or you can use the procedure to take care of this. Second one also, here also the process the control flow should be used for logging. Okay. So here it whether it can be a dimensional model or star dimension, star schema or snowflake schema, whatever it is. So you can always take care of the cleansing of the data and the quality checks and any other things that you wanted to do, like dimensional modeling and all, you can do it in the silver layer. So now this is the last layer. This is, you can say, like presentation layer also you can call it as. So here you will be taking care of, aggregations or any other stuff and creating a views to downstream. Creating views to downstreams. Downstreams like Power BI, ClickSense, Oracle BI, Oracle BI, Tableau, etc. Okay, so this is more or less how you can usually how the process of data engineering will happen in as part of the Snowflake. Thank you, everyone. Please feel free to comment in the comment section for any new videos required.